All right, my lovely Common Core 2 students, this is the video for the homework over the weekend. Part 1 is probably just going to be these 3 definitions and the first 6 problems. I imagine it'll probably be about 3 sets of videos. So let's go ahead and get started. Ideally, what I'm looking for in these 3 blank spaces are the SOHCAHTOA words. So for example, sine is opposite over hypotenuse. Tangent is opposite over adjacent. And cosine is adjacent over hypotenuse. And remember, our phrase for kind of keeping those things organized is SOHCAHTOA. The first letter is always one of the trigonometric ratios, and then the next 2 letters let you know the order of the fraction. Whatever's first will be the numerator, and whatever is second will be the denominator, right? So TOA, T is for tangent, and then our OA, opposite over adjacent. I think this is something you guys are doing a very good job with. So this is kind of what I would consider correct. Since we have this question up, I would like to remind you guys that if we had a graph in standard position that used the XY coordinate plane and the angle was based on a point, then we use some different vocabulary. It more or less means the same thing. The words have similar meanings. They're just more appropriate for graphical context. So if this was a standard position graph, y over r would be the preferred symbols. This would be y over x, and then the cosine would be x over r. I think this is something we'll definitely want to review on Monday's class, because we haven't done it in about a week, and it's quick. I think you guys can figure it out as long as we just do a few minutes of reminders. All right. Next thing we're going to do is just knock out these 6, and we're going to do them one at a time. So what I'm going to do is kind of, each time we do a problem, I'm going to clear the screen and create kind of some workspace. So I'm going to make some workspace to do question 1. The instructions say determine which ratio to use and then find the missing values. So it's worth it to kind of label. If our angle is here, and we go across the triangle, we get our opposite. The longest side is always our hypotenuse. And then adjacent means touching or next to. So next to this 42 degree angle is our adjacent side. All right. So the work involves knowing which part of SOHCAHTOA to use. If we look at the question, find the opposite, know the hypotenuse. Adjacent is irrelevant, right? So adjacent's got nothing to do with this question. This is an opposite hypotenuse question. It's an OH, so it's a SO. We want to set up the equation. On the quiz, I really want to see a step that looks like this. Sine 42 equals x, because the O, the opposite, is first. Over 75. I want to see that. Make sure you do that. And we can go ahead and solve this. And I have the calculator up here. I don't want to show you not some tricks, but just some ways of doing the work and having a very accurate answer. What we do most of the time is we go ahead and check our mode. So, oh, good, I'm on degrees. That's good. We figure out what sine 42 is. And we take that value and of course we round it and we write it down as our next step. So sine 42 is 0.669. And then we have x over 75. And then what we're going to do here to solve for x is we're going to multiply each side by 75. So we're going to do times 75. That'll get rid of that. And we'll do times 75 on this side. So let's see here. How can we get an answer? Well, one thing we can do is take our calculator and take 0.75 and multiply it by 0.669. And we get a value, and I would totally consider this correct on the quiz. If you said that 50.175 equals x, I would be all right with that. But it's not perfectly accurate. For one thing, when we copy this number down, we round it. We only use the first three values. So it's not perfectly accurate. And then we wrote them down, and then we typed it. So at the moment, let's just go ahead and say this problem is done. It's done. This is the answer. Before we move on to the next question, I just want to show you one way to kind of type all this in and get a more accurate answer. Oops. So let's back all this up. Okay, so we've kind of rewound to the beginning of the problem. We have sine 42 equals x over 75. We're going to multiply by 75, right? That's a step. That's a very important step. Multiply by 75, multiply by 75. What we've skipped doing is converting sine 42 into an answer. Because when we type this in, we can type it all in as one step. 75 times sine 42, right? We don't convert sine 42, we just call it sine 42. And then we press return. All right, look, we get a number that's similar, but it's significantly more accurate, more precise. And if we were going to round it, we would round maybe 4, 7, we would round it up to 5. We have, look, 50.185, 50.175. This answer, the first answer was fine. This answer is actually closer to the actual value. All right, so I just want to point that in there. You can type in sine 42, 75 sine 42, and it'll multiply everything correctly, and it'll also multiply it with more precision. All right, let's just knock out the remaining 5. So like I said, each time I'm just going to kind of clear the screen and then create some blank space to do each problem. So we need some places to do question 2. So let's work on question 2. We have to find the value of x when we want to label our sides. If we look across a triangle, we can see that that x is the opposite. This is the hypotenuse, because it's the longest side and it's also across from the 90-degree angle. And this is the adjacent. All right. If we look at what's asked for and what's given, it's pretty clear that the hypotenuse is irrelevant. So we need a formula that uses opposite over adjacent. So this is going to be a TOA problem. And specifically, tangent 45 equals OA, so opposite over adjacent, x over 20. And what we're going to do is actually use that method of creating a more accurate answer. We know that to get rid of divide by 20, we're going to have to multiply by 20. So instead of converting tan 45, let's just go over here to the calculator, type in 20 tan 45. And what we have is, oh, well, look, we have a completely accurate answer. Our answer actually is a whole number. It's a little bit odd. Usually that doesn't happen. It has to do with the fact that this is a 45-degree angle. In other words, this is not only a right triangle, but it's an isosceles right triangle. So these two sides actually have the same value because of that 45-degree angle. All right. Let's do the next one. Let's clear this out. Make a little space. And we'll work on question 3. In question 3, what is asked for is not a side. What is asked for is actually an angle. It's still going to be SOHCAHTOA. We're just going to do it from a slightly different perspective. Let's label our sides. Even though we don't know this angle, if you look across the triangle, this is still the opposite. and then if this is still the hypotenuse, which isn't going to matter, and this is still the adjacent. So if we look at these ingredients, we are still doing some TOA. And if we set this up, it would look something like the following. Tangent x is 10 over 20. And if you want to go ahead and reduce that to tangent x equals 1 over 2, that's totally fine. It's not necessary for this problem. What makes this one different is that we're going to have to use inverse trigonometry. We're actually going to have to use these buttons that are above sine, cosine, and tangent. To solve in math, your goal is to isolate the variable, move everything to the other side, and get rid of whatever terms are kind of with the variable. So if this said 5 times x, we would divide by 5. If this said 5 plus x, we might subtract 5. What we need to figure out is what is the opposite of tangent. And the opposite of tangent is something called tangent inverse. It doesn't have a special name. Inverse means the opposite operation or the reverse operation. So this symbol just means the opposite of tangent. X is tangent to the negative 1/2. That will get rid of our tangent and solve for x. And that's a value on our calculator. If you look at tangent above it, I know it's hard to see on the video, but the button above, so push second tangent, is that tangent inverse. And we can type in 1/2. We can type in 10 over 20. It doesn't matter. I'll type in 10 over 20. And what we get is the value of our angle, which is 26.565 degrees, approximately. One way of thinking about what this means is to think of it this way. The mystery is the angle. So this is saying, okay, what's the angle that would have 1/2 as a tangent? If 1/2 is the tangent, or if 10 over 20 is the tangent, what angle goes with that? That's one way of thinking about the inverse operation. It's working backwards. I know the tangent. What I really want is the angle. So tell me the angle that has this tangent. All right. Next question. Question 4. Make a little room for it. In this one, actually, we have to find 2 different unknown values. We have to find the value of x and the value of y. The key is not to overthink this problem. Let's just take it one at a time. Let's do x first. So we can ignore the y, pretend the y has nothing to do with this question. We have an angle, we have an adjacent, and we have an opposite. And for the moment, we're just ignoring y. So we have an adjacent and an opposite. This is another tangent problem. It's another TOA. Tangent 53 equals x over 50. This is one of those cases where you could convert to a decimal, and if you do, I'll still love you. But I do want you guys to know how to be accurate, and the best way to be accurate is just to say, oh, well, it's going to be 50 times whatever tan 53 is. So 50 tan 53, according to my graphing calculator, is 66.352, well, let's stop there, 66.352 degrees. That's our value of x. Now that we actually know 2 sides, we have multiple. We're going to go back and look at y. So remember this guy. We had to find that y value. We actually have some choices. Now that we know these 2 sides, we could use the Pythagorean Theorem. We could say that a squared plus b squared equals y squared or equals c squared. However, I think it's worth it to use SOHCAHTOA for this one because it does have some steps that we haven't done yet, and I want to make sure we get those in. So now we can ignore the opposite, and now what we care about is the hypotenuse. So if we know the adjacent and we want the hypotenuse, this is going to be a cosine problem. All right, so let's kind of ignore this, get this out of the way. This is going to be a cosine. This is going to be a CAH, or in other words, cosine 53 equals the adjacent, which is 50, over the hypotenuse, which we don't know, which is the value of y. So here's the reason I want to do this one this way. It's a little bit odd because the denominator is the unknown. The good news is we always do the same step. We always multiply first. If you multiply by y and if you multiply by y, that's going to be your first step. So let's say that we now have y cosine 53 equals 50. Instead of divided by y on the right side, we've made it multiply by y on the left. Our goal is still to solve for cosine 53. We can convert it to a number, but look, what's going to happen to this is we're going to divide. Right? If this is multiplication, to solve, the opposite is going to be division. So what we really want to know is what is 50 divided by cosine 53. And once again, that's something we can type straight into the calculator, and we'll be more accurate in our result. So 50 divided by cosine 53. We get a value for y, which seems to make sense. This picture's a little bit screwy. You may be saying to yourself, look, if this is 50, there's no way this is 83. It looks only slightly longer. I think it's because this is doesn't really look like a 53-degree angle. It's always important to recognize pictures might not be drawn to scale. Make sure you do the numerical work correctly. And usually your answer should feel right. I think this answer feels a little wrong, but it's fine. That's our y value. All right. So like I said, if we go back and look at the blue, what really mattered there, cosine 53 equals 50 over y. Remember, multiply is always our first step. So multiply by y, multiply by y. Use the appropriate operation, and then divide. So these are always two steps. When it's the top of the fraction, it's a one-step problem. When it's the bottom of the fraction, it ends up being a two-step problem. Let's take a look at, I think we're going to jump down and do 6, just in the interest of keeping these videos from being too long. If you really do have questions about question 5, I'm sorry. I decided to skip it, but I really, really believe that you can figure it out. The reason I want to do 6 is it's another one that has those unknown angles. And let's actually do that part first. Let's do the unknown angle first. If we label our sides, the two sides we care about, if this is the unknown, then what we're really doing is we're ignoring this question for later. This is our OPP. This is our ADJ, our adjacent. Sorry, that's not a very good way to spell adjacent. And if we set up our fraction for this, opposite adjacent, that's tangent. So this says tangent x equals, oh my goodness, hold the presses. I've gotten so far ahead of myself. This is the hypotenuse. Sorry about that. That's the hypotenuse. This is not going to be a tangent problem. If this is the hypotenuse, which it is, and this is the opposite, this is a sine problem. This is an SOH. So the sine of x is opposite over hypotenuse, so 9 over 30. So this is another case where our goal is to solve for x, which means we have to get rid of sine. Well, how you get rid of sine is using the opposite of sine. That's how you get rid of anything in math. So we need to know sine inverse 9 over 30. And that's something we can just type into the calculator. Inverse, you have to push second sine. And look, this looks like a -1, but it's pronounced inverse. It means reverse, or it means backwards. And we get the value for our angle, which is 17.457. Or 17.458, I think, if we round up. If we look at the prompt, we have another thing to figure out. We have to figure out that y value. So we're going to do things a little bit differently for this one. We're going to use the Pythagorean Theorem. It's important to understand, if you know two sides, the third side can always be done with Pythagorean Theorem. The key for this one is recognizing that we know the hypotenuse. So really it's 9 squared plus y squared equals 30 squared. What I actually like to do is write this all as one operation. So we can move 9 squared with subtraction and say that y squared equals 30 squared minus 9 squared. And then we can undo the square root here, the square here, by doing square root. So square root y squared equals, and then when you square root, you got to square root all of the left and all of the right. And what I mean by all of the right is you put it all under the square root symbol. If we do this, this will undo our value, our squared and our square root, and y will just be whatever this is. There's more than one way to work this out. The reason I wrote it in this order was because I wanted to remind you guys that this looks a lot like the distance formula. In fact, it is the distance formula. There's a strong connection between distance formula and Pythagorean theorem. So I think if I do the steps in this order, it reminds you guys of that. Plus, we can type it all into our calculator as one step. Big square root, 30 squared minus 9 squared. Close the parentheses, and then we can do all of kind of the number crunching in one step. And we get a value for y, which is 28. Oops. We get a value for y, which is 28.618. We could have used SOHCAHTOA. Once you know the angle, you can use SOHCAHTOA. So if you found x first, you had a lot of choices. If you solve for y first, if you did this first, you had to use Pythagorean theorem. If you did it differently, you did it wrong. Please check your work. All right, that's the end of the first part of the video. Hope it helped. If you have any other questions, click on the next one. I think I'm going to jump down to some of the word problems. I don't think I'm going to do the entire worksheet because some of the questions are very similar and I would like you guys to practice.